This demo will show how Apstra uses intent-based analytics and root cause identification to reduce mean time to resolution. Juniper Apstra leverages intent-based analytics to manage data center fabrics. It manages a network fabric as a single entity rather than a collection of individual devices. In this view, I'm showing the dashboard of an operating data center fabric in a remote location. Earlier, one of the devices in my network was experiencing problems, and a technician replaced that device. This display reflects the status of the network after he has the new device. You can see that I have BGP anomalies, some cabling anomalies. I've got route table anomalies. All the individual devices appear to be operating in a healthy state. But in this node status view, I've got different size red dots that indicate the number of anomalies associated with each category for each device. For example, border rack leaf 1 has 2 BGP anomalies, 1 cabling anomaly, and 9 route table anomalies. Let's go to the Active Network tab and see the topology. From this view, we can see all the devices in the fabric and a color-coded status for each one. On the right side, I have the telemetry coming from all devices in the fabric. This reflects the same information we saw in the dashboard view. If I want to drill into this specific leaf device and see more details, I can see there are 2 route anomalies, meaning that I have 2 routes missing from the table. Apstra knows from the intent model what routes should be present, and it compares the current state to the intended state. This is what is meant by intent-based networking. If I go into this spine device, I can see that I have a number of additional anomalies, cabling BGP and routes. A graphical map indicates something is wrong with the cabling in this device. This is the device that was swapped earlier by the technician in a remote location. If we go to the root causes table, we can see that there are 2 root causes have been identified based on the anomalies that are present in the blueprint. I can see 3 devices associated with the root causes: Spine 2, Border Rack Leaf 1, and Border Rack Leaf 2. The tabular view is going to give me details about how these root causes were identified. Root cause identification is telling us these 2 spine leaf links are down. It determined this because of the relationship of the associated anomalies to the intent-based model. Traditionally, the technician in the remote location would have to go to the location in person and examine the rack and the device and the cables that he installed. But Apstra gives me a more efficient way to resolve this problem. By going into the Stage tab and into the Links table, I can pull the current LLDP data from the devices. This is the same information that was used by the root cause identification process to identify the problems. I can update this cabling map from that data. And by updating, I'm going to have the system configure the ports for the appropriate devices on the other end. The new configurations will show up in the Uncommitted tab for review. We can see that the tabs turn yellow. This is a pre-change analysis that allows me to verify what's going to happen before pushing the changes to the production network. In this case, these links are going to be swapped. All looks good to me, so I'll commit that. I will write a note. When I commit staged commands, Apstra sends instructions to the agents, and the agents determine the appropriate command line syntax to apply to the devices. This is what we mean when we say, you specify the what, and Apstra will take care of the how. It only takes a moment for each agent to detect the new state, and the anomaly indications are resolving. You can see how they are all turning green. Let's go back to the dashboard view, and you can see that all the anomalies are cleared, and the network is operating in the intended state.